So, and obviously looking around, there's some pretty big bits of kit and there's a lot of stuff. So could you maybe explain a bit about how it was actually installed and why it was so important to not have an impact on the forest?
Yeah, for sure, Niall. So what you can see when you get up close to this infrastructure is that these big metal towers are not in a regular array. They're put in the gaps in the forest. They were lowered in by helicopter, by a very special helicopter and a very special helicopter crew. They're not guyed in place. They're bolted onto these platforms I'm standing on partly just now, and the platforms themselves are screwed into the ground using these enormous screws. So we had a big team of builders in here in the forest for about a year, just screwing the platforms in, rather than taking big diggers and heavy machinery into the forest. Because once you start churning up the soil, you break the connection between the plants and the microbial communities. And we were very, very concerned to minimize that. And then in the canopy, we wanted to minimize breaks, openings in the canopy that let light in and change the ecology around each patch. So those were the instructions we gave the engineering team. And actually, they were brilliant. They totally got it. They totally could do it. So when they were given that as the remit, they could do it. Yeah. Of course, if we hadn't told them that, the sensible thing to do is just flatten the place and then put the trees back when you're finished. But exactly. We explained to them why that's not possible. And I think in the built environment, there are lots and lots of situations where that same conversation could happen. It's just not possible to flatten everything and then put a tree back in and expect you to be having the same kind of ecological and environmental service that you had when the tree was in its right place.
No, definitely. I mean, the screws you've got here, the big steel screws going in, that's something that's being used now in a lot of sort of root protection areas when you have to bridge over tree root systems where you've got to have access through them or whatever as an alternative way of having a very, very low impact. You know, there's so much technology now as well to scan where roots are.
Yeah.
You can go and actually see where the roots are and pick the points where you'll miss them. So there's even less impact. So actually it's a very, very low impact way of construction and how to approach problems.
That's brilliant. And that ground penetrating sensing, ground penetrating radar is fantastic technology. It's a little bit hard for us to use in a situation like this where everything is kind of interconnected. We haven't got a standalone tree. And a lot of the roots that we're interested in the first instance, the roots that we're interested in are very, very fine, 1 millimeter in diameter or even less. And so we have to use different techniques to see those. Sometimes we have to take a cylinder of soil away and process it in the lab. And we'll process it for roots and for microbes and for chemicals, particularly the nutrients. Other times we use video cameras fed down below ground through Pyrex tubes, and then we can just time and again look at the same piece of soil and watch the root growing month by month through that through the season. And another of the so one of the results that we've seen since we began is that increase in fine root growth in a patch like this that has got extra carbon dioxide being fed to it. So although the carbon dioxide is coming in via the leaves right up at the top, so 75 feet above my head, and we have to make measurements of that, and we make measurements by winching our researchers up on a chair with their piece of kit, like the kit that Carolina is using today. And but what we're seeing is changes up at the top of the canopy, provoking changes below ground.
Yeah, no, it's really interesting. I mean, so why is it you're up in the canopy? Because that's where all the photosynthesis takes place.
Yes, exactly. Yeah. So of course, anywhere where you can see a leaf around you here, the plant has gambled that there's an opportunity for photosynthesis. And generally speaking, if the leaf looks healthy, then it must be getting enough light to allow it to generate photosynthesis and generate sugar. But the major part of that is happening in the most sunlit part of the canopy, which is, as I say, 25 meters, 75 feet above our heads.
Yeah.
There's, I mean, we can also look at other things that are happening up there around insect assemblies and so on. But principally, we want to get up there to measure the carbon coming into the forest. And then everything we're doing below here, at this level and below ground, is about carbon being stored or being lost from the forest.
Okay, fascinating. And what other experiments are you doing here on the ground? Because there's a lot of stuff